Good evening, everyone, especially to those on our YouTube channel. Could you please let me know if I am audible? You can type it in the chat box on the right side.
Chat box. Yeah, we can hear you.
Sorry, Ashok, I was just asking the YouTube audience if they can confirm. Yes. Just give me. There's a 20-second delay between Zoom broadcasting into YouTube, so it takes a bit of time. All right, great. It looks like you can hear me, which is great. So good evening, everyone, and welcome to today's session on automating automotive design, bridging the logical and physical world in harness design by Zuken India. So today we have MS Ashok, who's the director of Zuken India, and Ramakrishna, application engineering manager at Zuken India. Ashok is an engineering professional with over 35 years of experience in the electronics industry, covering test and measurement, GPS technology, and embedded system software development. He has a varied and rich experience in setting up greenfield teams and business units, project management, and managing company operations with P&L responsibilities. Ramakrishna is an engineering professional with over 20 years of experience in the EDA industry, covering PCB, electrical wire harness software solutions, and process automation. Zuken India is a Silver Plus sponsor of the Formula Bharat 2021 event. So without further ado, Ashok and Ramakrishna, I'll let you take the front seat.
Oh, thank you, Kathy, and very good afternoon to everybody who's participating online in this. First, I guess this is the first of the presentations under Formula Bharat 2021. We do have spent a greater part of this year realigning in the manner in which we speak, communicate, and are able to exchange information. So I guess all of us have kind of reached a good level of comfort in being able to, sit through presentations like what we are going to do today. It's been a very interesting journey with Formula Bharat. I had personally been there 2 years ago at Coimbatore to see and understand what's been happening, what was happening with Formula Bharat. And frankly, we were quite amazed at the energy levels and ideas which our young friends bring to the table for design activities. And that set us thinking that we should therefore certainly be participating. And since last year, in 2020 also, we've decided that we're going to be actively involved with Formula Bharat as a sponsor. And so continuing that this year too, we are there as sponsors. As part of our presentation today, we shall be talking, giving you a quick background about our company, Zuken, and we will also talk about some of the technicalities of automating automotive designs. I have my colleague, Ramakrishna, who's our system AE manager, who's got a lot of experience with our tools, and he will be sharing part of the presentation with me. Next slide, please. Right, so as I mentioned, we will do a quick introduction, and then we will talk a little bit about the market for automotive electrical equipment. So this presentation is going to give you a bit of an insight into what's also happening in the automotive marketplace. Of course, this year, everybody is kind of, wondering whether, how things kind of seem to have collapsed, but they haven't really collapsed all around us. And things are starting to look better as we go forward. And there is a market for automotive electric equipment as much as automotives. And then we will spend some time to talk about how Zuken provides solutions for automating the designs in automotive, right? Especially with respect to cable and wire harness. Next, please. To give you a brief introduction for our company, Zuken, some of you who may have gone to our website or have heard of us, we are a Japanese company, and we have a long history in this field of electrical CAD work. We started way back in 1976. In fact, as of 3 days ago, we completed all of 44 years of existence in this field. So we are recognized as one of the pioneers in this area, and also uh, we are also one of the market leaders for the kind of tools that we provide to the designers, electronic and electrical designers. We have our headquarters in Yokohama. We also have our European headquarters in Germany, the US, in Massachusetts. And then we also have one product line which is called E3, which we will be talking about today. That is the technical headquarters are also there in Germany. And then the company has been very profitable over the last, ever since its inception, and we've been growing year on year. So we are a public limited company, and we're traded on the Tokyo Stock Exchange. Next, please. So Zuken in India, we came into India in 2015, and we are actually located here in Bangalore. Our office is in Bangalore, in the Central Business District. Or those of you who are familiar with Bangalore, we are just off MG Road. And this office provides application support and marketing and sales operations, and in addition to some other technical activities which we do for our internal teams. Zuken is, like I mentioned, a organization which works across the world, and not only do we have very large customer base across the world, and so also we also have a large customer base in India. Some of the names that you see on the screen are quite familiar, and a lot of them are also present in India. In addition, there are large Indian organizations which have very extensive usage of our tools. In fact, it's a matter of pride for us to inform everybody here that the ISRO, or Department of Space, is one of our largest installed base in the country, and we feel particularly proud that almost 95 to 97% of all PCBs which fly on satellites and rockets, and also a lot of the wiring which goes on into our launch vehicles out of the PSLV, are all designed using Zuken tools. So we have a very close connect, and it's a matter of pride that we are involved with an organization like ISRO. Of course, in addition to all these industry, and like I mentioned, we also support the student formula teams, and as of date, we are currently supporting as sponsors about 9 different student formula teams across the country. Yeah, and we keep looking and evaluating teams as we go forward, so that we can help them with our design tools and give them some understanding of how they should use tools to improve on their designs. Next, please. So Zuken is really a technology company. Yeah. Okay, I think we have a slight speed issue. Okay, there it comes up. Yeah. Okay. So we are an engineering company, and we have a large investment into R&D, which goes on. That's what keeps us at the head of all kinds of new requirements which the industry throws at us. And there are specific areas which we work on. Of course, our R&D is centered in Yokohama. But however, there are specific areas like signal integrity and electromagnetic interference studies, which are done out of Germany. We have a lot of automotive and transportation work done in Germany again, PCB work in UK. We also involved with IC packaging, integrated circuit packaging, and that kind of work takes place in the US. We have more than 40% of our engineering resources is in our engineering resources. And the interesting thing is Zuken's world. Technical staff is about close to 500 people with an average tenure of 12 to 15 years. So there is great continuity in the organization, and people who use our tools find that very effective, and people who work in Zuken find it very challenging. Next, please. What I would like to also therefore talk about is what is it that we do. We broadly said that we are in the electrical electronic segment. So we provide essentially software design tools and some services associated with that for the electronic and electrical product development. So anybody who does circuit design, electronics requires the tools, the entire physical realization of the product is there is a PCB on which the components would sit. And there's a lot of wiring in any system. And so we essentially are providing software design tools for these two activities. So across industry, industrial machinery, consumers, aerospace, military defense, in some areas we are very strongly placed. We do a lot of work with the railways, automotive, and aerospace, in as much as we do military and industrial equipment. Next, please. So, in terms of what we actually provide, the way to clearly understand the positioning of our products and what we do, if you take a look at any particular product design, which also has electrical and electronic parts to it, it invariably starts with a logical design. Then you're basically figuring out, okay, this is the logic within the system, and therefore it comprises of different parts. You would do some kind of circuit design planning, and then you may have electrical interconnects, not only just power but other relay systems and things like that, and then you may have some fluid hydraulics running across the whole system. And so therefore at this level, first part is always logical design. How do I conceptualize and do that? Every next step which I do would be to have the physical design. That's when I move my logical design to a real physical realization. And then at this point in time, your designs would go into having different types of PCBs, manufacturing of all of that. In terms of electrical things, you may have cabinets and panels which need to be interconnected, and then you may have you do mass production, so you need some way in which all this information is sent to manufacturing as wire harness and form board. And as always, there's a lot of documentation required. So you have design files, you have manufacturing and design instructions. And eventually, as the whole process moves forward, you have a lot of data. And so you have to have some manner of data and process management. At each of these stages, there are some very specific requirements which drive the manner in which you do. In the logical design phase, you have the ability to enable designing, do a lot of analysis, and do a lot of visualization is important. And then when you go into the physical realization of the product, you would want you need the ability to have engineering productivity. You should be able to very quickly physically realize the concepts which you are deciding to do. And once you are ready with this, and then you have tested and you want to go into production, you should have all the necessary information and be able to manage the production process and the life cycle of the product. Right. So over this kind of environment, we provide the solutions as such. Next, please. So if you see across our logical and physical design, we have two product lines. One is related to the printed circuit boards design, and the other one is the electrical one, which we call E3. So where we do, as I said, from logical planning, designing to circuit and physical layout with PCBs, not just single PCBs, but today PCBs have become fairly complex. They take all kinds of shapes and sizes. In fact, we also have flexible PCBs. So if you take a look at your phone, the PCBs, it sometimes contains more than one PCB. And these PCBs, given the size of the entire system, are folded. So sometimes you have flexible PCBs. In the electrical side, where you have a lot of cabinets and panels, so we provide the E3 series. With all this data coming in, our solution in what we call as the DS, or data engineering data management system, we provide solutions which allow the designers to have good control on their engineering design information and management, so that version controls, life cycle management is handled better. Next, please. So just to give you a quick sneak peek at some of our products, our CR8000 family is our flagship product. And this is a enterprise level product. We have two families here. One is called the CR8000, which I'm referring to. The other one is called ECADStar. ECADStar is more at a single point, single usage or single board design tool set. CR8000 is a enterprise version tool. Fundamentally, both tools really do similar things, though CR8000 provides a larger landscape and more features and capabilities, starting from system planning so that you can optimize the layout and all the break down your design into different parts and boards. And from there, you go ahead to do what we call as design gateway, where we allows you to create all the schematics and run your calculations and run simulations to see that your designs would basically provide you the kind of outputs that you require. Data then flows into design force, where we are actually doing the physical layout of the PCB. The interesting thing about taking with CR8000 and ECADStar is the fact that you do work both in the 2D world as well as the 3D world. So you would actually be able to simultaneously work on a PCB layout, looking at it both in 2D as well as in 3D. So it also allows you a lot of other design rule checks, ensures that your design is right at the first instance. And subsequently, we have another module which looks at design for manufacturing. So, especially companies who manufacture, tons of equipment. So they may go in for building a few 100,000 pieces of this. They also have a manufacturing process for panelization and create multiple PCBs. So we provide tools to ensure that what you will eventually realize in the physical form is exactly the way you designed it. And with all this tools and modules in place, we also have a very robust library and data management, which forms the core part at the back end of the tool. Next, please. This was as far as this PCB is concerned. The next tool bit we have is on the electrical side. So the electrical side family is called the E3 series. Now, E3 series again is more from an electrical perspective, interconnect of cables and wires within the system. And here again, we have the tool giving you the authoring capability to create circuit diagrams, make production documentation, customer documentations, installation service documents. And from the circuit designs, we go into making other views of the schematic, including creating wiring diagrams, which basically says, okay, these are the bundles of wires which will go through and therefore form the cables. And then based on the kind of signals and requirements within the system, you can put in other details to the cable information. To give you a reason why cabling design and wire harness design is very important, I will show you some pictures in the subsequent slides. But just to bring that into perspective, a typical automobile, high-end automobile, for instance, if you take BMW 3 Series 3, if I'm not wrong, and if you were to lay out all the wires in the car end to end, you would have close to 5 kilometers of wiring. So you see, this level of wires to be handled requires necessarily a good tool, which allows you to set up a proper schematic and proper layout and do the cabling. And of course, with a lot of other areas of application like aircrafts and machinery, we also have the cabinet and form board layout. So form boards are an important part of this tool, where later point in time, in the second half, my colleague Ramakrishna will talk about the form board and how we automate that. Form board is like a one-to-one representation of your design on which you go to manufacture the harness. Yeah. E3 also supports hydraulics and pneumatics. So within the same, a lot of systems, for instance, industrial systems for that matter, actually have hydraulics and pneumatics running in the system, along with the electrical control. So you have solenoids which are controlled electrically, but these solenoids actually operate some valves or some, measurement sensors along the way. And fluid engineering and hydraulics is also handled by E3. So in complete, both these tools give you a complete set of design process authoring tool for the PCB side as well as the electrical wiring side. Next, please. And finally, of course, the fact is that there's a lot of data now. When you're doing a design of a product, invariably, if you take automobiles, for instance, you go into an automobile showroom and then you take a look at the model that he has. You go into a Maruti's showroom, and you say, I want to take a look at Alto. And then he will say there are 4 variants to the Alto, right? And so you have petrol, diesel, you have something with additional bells and whistles, like something comes with 6 safety, 6 airbags. The entry model doesn't come with airbags. You find yourself with a lot of options and variants. And obviously with each option and variant, at the back end, a lot of the electrical activity, the electrical connections, and also the PCBs or the ECUs which run inside the car would also be different. And each of them, therefore, calls for its own set of drawings, calls for its own set of manufacturing information and servicing information, and so on and so forth. Very quickly, any product lands up having enormous amount of data. So what we recognized is that good engineering data management is key to a successful way of not only designing and producing, and therefore managing the life cycle of the product. So we have a solution called DS2, which in particular for PCB is called DSCR, and for the electrical side, it's called DSE3. And here we manage the component library, we manage design data in terms of good version control. Yeah, as you're aware, and you should also know that design is an iterative process. So you would run through designs and then you go through an iterative process before you freeze your final design. And in the bargain, what can happen is you would have a bunch of versions which you would use. And at some point, you decide a particular version is the one which you will release for production. But you still hold on to the data from the other versions, maybe for future use or maybe for future review, right? So all these activities are managed under the design data management, which therefore allows also a good control to the design team. So we have a concept of centralized library management so that the designers would use only approved parts, right? And there is also good lifecycle management built in, which allows you in later point in time to be able to understand how any, let's say, obsolescence will affect you. You a lot of times hear about automobile companies, issuing a notice and saying we are recalling for some correction of the vehicle. How do they do that? They do that by taking a good system at the back end, which allows them to do management of all this information. So using a management tool like this allows them, for instance, to give you an example would be, let's say a particular relay was proving to be faulty. And there are a lot of cars which are out there in the marketplace already delivered when this problem has been noticed. The only way a manufacturer like, say, Maruti can identify this is they would use a data management system like this. to go in and do a query and find out which are the versions of or where this component has been used. So the system would come back and say, okay, this component has been used in all the following modules, and these are the versions which of the module designs which have been released to production. And from there, they can really figure out from production as to which serial numbers of cars had this particular module and version. And then the company will issue the recall, and then you take your, if your car is one of those serial numbers, you take it back to them. And in the meantime, engineering would have made the necessary changes, and so they are able to do a track and replace and do the correction. So data management has now become a very critical aspect in terms of the life cycle management. And since we are all talking about design, manufacturing of electrical and electronic systems and subsystems, Zuken provides the end tool also, which helps in this activity. Next, please. So say we at Zuken, therefore, are focused on providing, or what we say, empowering the designer. Designers, as they keep pushing the boundaries of their design and physical realization of the product, they come back and say they pose the challenges to us. And so therefore, there are areas of work which we do which are essentially meant to empower the electrical and electronic engineer. Authoring tools, as we have been going forward and you've seen over the years, we have been seeing the form factor of so many elements or so many systems becoming smaller and smaller. If you just take the case of something like the phone, the mobile phone, which one would, even if you go back as late as 3 years ago to what you see today, has seen enormous change and in terms of the form factor, size, and fit. So therefore, there's been a lot of activity in how we provide our tools for authoring. We have more design domain data management requirements which are coming up. Today, the world works not just in one place. It's geographically spread out. You may be part of a design team sitting here in Bangalore, working along with a team in Pune, which is connected to a team in China, and all managed by somebody sitting in Germany. So therefore, reverse the previous slide, please. Yeah, so domain data management is becoming more and more challenging. And of course, there's a requirement of scalable solutions. A lot of companies start small and they would want to invest as they go forward, as they grow. And this is one of the areas which Zuken works very well, and probably provide major amount of process management and cross-discipline integration with MCAD. Yeah, so next slide. Okay, very quickly, I think I need to speed up a little bit. So very quickly, I would like to say that, since we are all talking about automotive and automotive electrical, there is a lot of momentum in the automotive electric equipment. So over the last couple of years, we have seen major changes happening in the industry, whether it is EV related electric vehicles or even with the combustion engines. So combustion engine vehicles, have had more electronics built into them than in the past, right? Just to give you an example, the Mahindra's XUV 500, when it was first introduced, had about three or four ECUs. Today's version of the XUV 500 has more than 25 ECUs inside the vehicle. And mind you, this is still a combustion engine, right? So there has been great increase in the automotive electrical equipment. And there are some surveys which are pointing to the fact that this is an ever-growing market. This year notwithstanding, I mean, everywhere it seemed to have come to a certain halt, but companies don't just design and manufacture for the present. They do it for the future. So there is still a lot of activity, and there is still a lot of action going on with respect to the electrical automotive equipment. And EV is providing new challenges and new areas of work, especially with a lot of sensor activity and sensors which are being required for, and ECUs that are required. Next, please. A very quick, as of today, if you see, the EV market itself is very crowded, right? Depending on the size of the vehicle to the electrical mileage range. Uh, in the past, there were very few, but today it's already looking like a crowded market, and everybody is still working to improve. So there is a lot of activity which is happening on the automotive side, and the most interesting changes are that software companies are becoming car manufacturers. So Google has a car project, and it's one of most well-known projects which is going on. In fact, they do a lot of work out of India on this car project. So it's just not the standard automotive companies, traditional automotive companies, but other companies who are also actively engaged in the automotive, especially the EV boom. Right. Next, please. Okay. So what happens is that there are some very specific characteristics which are required as far as automotive electric equipment is concerned. You have, like I mentioned, a lot of variants. Today's cars are looking at miniaturization and power saving on the platform. There is a lot of focus on safety and reliability, and there have been safety regulations like the ISO 26262, which bring in a lot of focus on safety, and the entire design approach needs to ensure that the car design is inherently safe. And this also brings up how it is actually done and managed, is that there is a requirement for the designers and the manufacturers to have a lot of traceability and provide evidence that they have designed it well, and they have tested it well, and they have the evidence to show for it. You might recall that 2 years ago, Volkswagen got into trouble with relation to the exhaust emissions thing. How did they get caught? Because there is a requirement of traceability and evidencing, and somewhere in that process, if you try to cheat the system, you get caught. So the whole process has now been being driven in such a fashion worldwide that there is a lot of focus on safety, reliability with traceability and evidencing. And also is the fact that we are moving towards a lot of automated driving. We have electric vehicles. There's a lot of focus on autonomous driving vehicles, which is bringing into focus high-speed designs, so both for safety, and we don't want a car to automatic car to just stop halfway anywhere in between the roads, right? So there are a lot of requirements for high speed activities. So these are some of the broader characteristics of automotive electric equipment today. Next, please. So I will very quickly just place this whole thing in front. There are a lot of design issues which come up from conceptual design, going through circuit, PCB and wiring, creating proto evaluations, going for mass production. So as you can see, the entire concept to realization has a lot of major issues. And in this process, you need to be able to, can we have the next one, please? We need to be able to manage on the entire approach by using good set of tools, right? Broadly, this whole landscape can be actually broken down into three areas. One is everything to do with the design scheme. The other one is how do you go ahead to design and do the evaluation of different technologies. And finally, like I had mentioned earlier, data management is very key to the whole aspect of it, right? So these are some of the major issues in development, and Zuken provides solutions for that. Yes. Hello. I seem to have lost.
No, we're still here.
Oh, okay. Yeah. Sorry. Okay. My screen suddenly went blank. Okay. I'm back. Yes.
Okay.
All right. not only are there issues related to the electrical and electronic side, but we also have mechanical design challenges. So these are, in addition to the electrical electronics. So electromagnetic performance, strength and stiffnesses, thermal, durability, noise, and gearbox. All these are if you in sum total give you the picture of the necessity to have good tools for you to handle the design process, right? Next, please. To also give you another perspective into the whole thing, I'm quite certain everybody recognizes this. This is the most glamorous side of the electric vehicle family, right? This is the Tesla. And I've had the good opportunity to actually sit in it and drive. It's an excellent vehicle and it's a phenomenal engineering. Interestingly, from a perspective of cable and wire harnessing, it looks so sleek and nice. If you see the next slide, that shows you the innards of the wiring of the drivetrain for Model S. As you can recognize, what it looks so nice and sexy outside, the innards are quite complex. There is a lot of cable and wiring, and it goes all over the vehicle. Next slide will give you another view of the complexity of the Model S wiring harness. So this is the kind of wiring which goes inside a vehicle. And this is Tesla, right? And an electric vehicle. And to give you another perspective, even in a IC engine, if you were to take a pure 3D view, this is what you would actually see in a car with all its wiring, looking very much like a human being's blood supply system. As you can see, therefore, there is a level of complexity involved in not only visualizing this whole wiring system in conjunction to the overall system itself, the mechanicals, but also the entire manner in which you're going to produce this. Don't forget that there are companies who produce 1 million cars in a year of a particular model. And the ability to manage that requires you to use good tools and processes which help you to do this very well accurately all the time. All right. So this is where it starts to get interesting. And at this point in time, I'd like to hand over to my colleague Ramakrishna, who's our application engineering manager, who will now take you through how we manage this when we have to design and physically produce a structure in reality like this. So Ramakrishna, over to you.
Yes, thank you very much, sir. Yeah. Yes, as we move across, we talk about empowering the engineering with Zuken design tools.
Ramakrishna, could you just turn on your camera, please?
It was on, I think. So.
Yeah. The camera is on. We can see you.
It's on, right?
Yes, confirm.
Okay, thank you. Yeah. Okay. Yes. So to start with, to automate the harness design flow, so these slides explain the entire flow from electrical drawing to the harness drawing and finally to the manufacturer for producing the harness. So a typical part may have a top level, a functional or a topology drawing, as we see on the left side of a sample car drawing over here, and a detailed electrical scheme of from what we see over there, which constitute the electrical circuit diagrams. From here, once we have those, then we move to the 3D environment, any MCAD. So either we take NX, CATIA, SolidWorks, Creo, Solid Edge. So all the standard MCAD softwares which is available, so those data can be transferred into the MCAD for mechatronics integration and design. So once we have those, the data inside the MCAD, so we perform other activities and then using Zuken specific tools back and automatically create those harness drawings. once we prepare the harness drawings, so then we have, then we give all the data for a specific, maybe a BOM or a harness net list or any other manufacturing information that is from the, can be given to the mechanical, can be given to the any of the harness manufacturers. So this covers the entire cycle from the electrical circuit diagram to the mechatronics integration through the 3D bridge, and specifically flattening and also preparation of harness drawings and to the manufacturers. So let's get into the details of each part of it. So electrical circuit diagrams, as we call it, as a schematics or a wiring diagrams. So this is prepared using as probably the interconnection of ECUs or sensors or any other systems. All this connectivity happens through the connector on the unit side. And of course, we have a mating side of the connector. So in the harness, those mating connector goes, and the interconnection is through all the wires. So the schematics is prepared with all those, the parameters of the connectors and wires. So what properties can go in? Like, let's say I talk about a connector. So what kind of terminals goes inside, whether this fits in or not, whether it's a gold-plated terminal or should I need a tin-plated terminal. So any kind of specific types of terminals which goes into the cavities of the connectors. So those things will be designed over in the electrical circuit diagrams. And maybe this goes into an environment where there is where the wire is not used. So we don't want any of those dust or liquids gets into those systems. So we use the wire seals for the connectors. So these are the additional parameters that we decide in the electrical circuit diagrams when we prepare the drawings. Then which kind of the wire suitable for the different kinds of activities that we, based on the current flows and all, decide upon the what kind of the wire that needs to be used. Maybe for other one is for the realization of a wire, you would wish to have different colors and cross sections of all the wires. So all this has been defined in the electrical circuit diagrams. Once that is defined, now maybe our circuit diagram is being built on the functionally, maybe different types of functions across our electrical drawings. Now you would like to group it physically, like how many types of harnesses that we want in our system. Let's say an engine harness, door harness, lighting harness. So we wish to group all those wires based on the our requirement, and then we group those harnesses and export the data to the any of the MCATs which is available in the market, and which are the standard MCATs that is available. So I'll probably quickly show you a video over here. So in case if there is any, so this is how the electrical software E3 is we are talking about. And so we have different types of the schematics over here. So lots of interconnections, and probably I'm talking about bridging the data. So we export the data, selecting the suitable MCAT softwares which is available for us. So then select this data and export the XML file which goes into the devices. So maybe when you use the splices, maybe specifically we run through the recognition of the splices in the tool, and we export the data over here. Export the data over here, and yeah, so there will be some, yeah, so the data is exported and the PLM XML file is being created. So I just wait here by the time it exports the data. So yes, so we have this XML file being exported. So once we have this exported MCAD file into the MCAD tools, so we talk about transferring this data for the mechatronics integration. That means we pass the data into the MCAD tool. The XML files which is prepared, it goes into the Zuken generated from the E3 CAD tool is imported into the MCAD. So what all parameters that goes inside is the connectors, the wires, the cables, the connectivity information all goes in here. So what we do based on the position of units, the connectors and the parameters like the collision, the mobile parts, the weights, the CG, center of gravity, etc. So the routing parts are defined in the MCAD. So once these routing parts are defined, the routing is performed in the MCAD. So that's what we are going to do is realizing the digital pin over here. So I just probably wish to play a video. So where we have a specific harness with all those connectors and in our tool. So once this is an MCAD tool in which, so where we are transferred the data XML file. And of course, we are further putting on the spline parts or the different parts in which where we are going to do the routing points over here. So the routing points are being defined. So with all the way we wish to do that, and probably with all those the parts and with any of the collisions which we wish to take care of it, where it should not do the, probably the routing should not happen in a specific areas of the car. So all these parameters are considered and provide those routing paths. Probably I'll just, for the ease of this thing, probably I'll move through the slides to a faster extent. Yeah. So I'm preparing the splices in between. So yes, so we have done all the paths defined in our MCAD, and then all this data comes into from the electrical tool, from the XML file. So we are to do probably automatic assign or the manual assignment of the connectors. So all this information flows in from the logical world, that is the electrical world, into the mechanical or the physical or the 3D world. So once this definition is been mapped, which is either automatic or manual, once that is done, yes, so now we get into so probably each MCAD will have a different methodology of populating the data and working with the data, but Zuken electrical tool, we can transfer to all the MCAD softwares available, and the different XML files is recognized. Yeah, here we can see all the wires has been routed, and the routed structures has been seen over here with all those connectivity informations which has flown in as an XML file into the MCAD. And see the wires within the bundles over here. Yes, in case we need it, we can export it to the electrical back. So this is what we perform in the mechanical tool by laying the spline parts and perform the routing of the wires within the system. So once we do this, now the 3D world is done. So now we wish to make the form boards or the harness drawings, and we wish to pass it to the manufacturers for the drawing. So we have the 3D structures in the MCAT tool, so mechanical tool, and now what we do is import the harness drawings, and here we automatically create those harnesses in Zuken. And generally what happens is the 3D structures, which we see in the flatten tool, so is flattened and then brought as a 2D format for the manufacturer. So because the manufacturer understands the 2D data formats. So then the harness drawings are populated with additional data for manufacturing, and then it is sent for the manufacturing. So once we have the 3D routing of this one, so we can, now I'm going to play a video of how we are going to perform the flattened 2D harness drawing. So this is an MCAT tool. So yes, so we have picking up this 3D structure, the routing structure, picking up the 3D routing structure. So once I pick up the 3D structure over here, so we have all the connectors and all the wires. So all the connectors which is available in the 3D, we can see all these structures. And see all those connectors, those terminals, and we extract the 3D structure out from the MCAT. Here, we call it a transformer. Once the topology is extracted, so having the 3D structure over here, so we can see all those. So now still what we see is a 3D structure. So now we do all the required selections of the main harness branch, and now we have a flattened 2D structure which is available. And now this is taken into the MCAT tool, from the MCAT tool. So here I'm going to import it. Here my form board is getting created. So form board is nothing but it's a nail board of 1:1 harness or a scaled harness. So now my 3D structure has become a 2D flattened structure. So this 2D flattened structure is now additionally populated with any of those further details like the connector tab wires or any other further. Like here I can do certain rotation of the segments and other things over here suitable for manufacturing. Yes, so the tables have been populated. Yes, so now once we are the form boards or the harness drawings are done, what we send to the manufacturer is, for each specific harness, is the bill of material, the wire cutting information. When we do the wire cutting, maybe we used to do certain extra lengths, like maybe we have a twisted pair. So generally when the two wires are twisted, so we are going to get the extra lengths of the wires, which is coming in here. So those extra lengths, and also maybe when you use the connectors, we want to have those extra insertion lengths. So those additional parameters will all be considered, and we generate a bill of material and the wire cutting information. Further to this information, so we not only provide, maybe there is a splicing information. We have some specific splices. So where we are doing probably certain three wires are coming in and two wires are going out when we do it for splicing for the ground and maybe for the power. So we wish to give it to the manufacturer that we say that, okay, two wires are coming in and one wire is going out of the splice. So, and probably we can see a report here, left and right. So where, how is my conductor coming and where is it going? So to the manufacturer, we send this data. And maybe we are using some specific tubes, which is maybe a corrugated tube and a specific kind of taping which is done. All this and the labeling information. So all this information is given to the manufacturer. And also we export to the any of those just in case we use the manufacturers are there. So they export the different formats of the data, like the labeling system, the wire processing system, the machine, the testing system. So all this we can export the data in a specific readable by the machine's format. So thus we start from the process of just to come back to my first slide. So where a recap point, so where we do the electrical circuit diagram and use Zuken E3 3D Bridge, transfer to all the mechanical softwares, whichever is used by you, and get the 3D structure and do the flattening and create the form board flattened 2D view and give the data to the harness manufacturer. So this completes the flow from the electric circuit diagram to the manufacturer. So coming to the last and the summary. So as we see, automatic designs are becoming more and more complex as we have a lot of sensors and other additional things which are coming in. So also this is also resulting in the complex harness drawings as well, or the complex harnesses as well. Hence we need, and also there is lots of safety and performance also is a part of the design activities now. Hence, for all this, we need to have an automation process right from the design to the manufacturing, and also which helps to avoid any of the critical failures so that we can ensure the early verifications and early performances that we do all this so that we can avoid any of those problems which is encountered later. Zuken tools sets, whatever we have seen from the PCB and also the electrical tools, helps in automating the above process and thus empowering the design engineers right from the design process to the manufacturing. So thank you, my dear friends.
Thank you, Ramakrishna. Thank you, Ashok. That was, I have to pull out one line that Ashok made during the presentation. He said, good engineering management is a key to the success of the life cycle of the project. And it was great how you explained how Zuken's products also, assist in this area. So at this point in time, we're going to open into the Q&A session. I believe Ashok has already been started answering some questions on the stream, but just because we won't be able to see the stream after the live session is done, there was one question by Abhishek, which is it possible to import schematic and PCB models from other softwares, example KiCad into CR8000? And Ashok responded with, KiCad is what we call point solution, whereas CR8000 is an enterprise tool. So short answer is no, not direct out of the box. There are workarounds to manage data transfer between different PCB tools. So we have a question from Shubham Singh. Can we make PCB schematics in CR800 and convert it into Gerber files to printing? And I believe Ashok responded that Gerber files are standard output. Okay, we have one more question from Abhishek, which was, what are the minimum system requirements to run softwares CR8000 as well as E3 optimally? You can respond via the video itself if you wish to, instead of responding via the stream, Ashok.
Yeah, sure. Okay.
Yeah.
Well, actually, to the question regarding the system requirements, PCB tools are a little more graphic, intensive than our cabling and wire harnessing tools. But typically a good workstation with multiple displays and a good graphics card, i7 with 8 GB RAM, good stuff like that. So there are not too many heavy demands as far as the hardware is concerned. Almost all our PCB tools provide you standard outputs, so of Gerber files, for instance, and all manufacturing data for PCBs. So whether it is drill files, screen print layers, uh, all the necessary information for a PCB manufacturer to actually manufacture your PCB. The PCB tools from Zuken also have a whole lot of analysis, functions built in, so that if you're designing high-speed signal, boards, you would also be able to do signal integrity and power integrity analysis of the layout, so that you can ensure good performance. Your the performance of your electrical design, whether it's on the wiring side or whether it's on the PCB side, electronic side, eventually means that unless your PCB is done well, your circuit will not perform well, right? And similarly, on the electrical side also, you may have all the connectivity, but if your, the manner in which you manage the wiring, manage the routing, and therefore provide all the necessary information for manufacturing, the physical realization of your wiring harness will not deliver what you originally intended from your design perspective. So for both of these for these activities, Zuken Tools provides you all the necessary modules and tools to ensure that you do your design right the first time and very quickly. Because like Ramakrishna was mentioning, there's a lot of automation built in from the point in time when you start doing your schematic, going into the final product documentation and for production, so that there is consistency in your design.
All right, great. I think those are all the questions, and I don't see any more questions on the live stream. All right, there's one from Shaili. Is Zuken software available complimentary for students?
Okay. The way we actually do it, if you would want to do something as far as learn a little bit, play around with the PCB, you can go to, you can get in touch with us. You can write to us at info@zuken.in.zuken.com, and we can help you with some of these, student versions. We do also, like I mentioned earlier, that we do specific work for the student formula teams. As of today, we are supporting and sponsoring about 9 different teams across the country for both the combustion engine teams as well as for the EV teams, right? This is what we do. If you're specifically asking for an individual, access of free software, well, not really. I'll be honest with you. We do have something which we can still share, but it's a slightly older version. So do get in touch with us, and we can see how we can help you.
All right, great. So I think we can end today's session on that. Ashok and Ramakrishna, thank you so much for taking your Sunday out to host this event and to present over here. To our participants and audience, thank you for logging in. We appreciate your time. If for more updates on future events and especially live sessions, please do subscribe to our channel. Thank you all and have a wonderful evening.
Thank you very much to everybody, and have a good remaining big part of the weekend. Bye then.
Bye-bye. Thank you very much. Thank you, everybody.
Thank you very much.